everyone for attending. My name is Robert Ofwete from Kenya. I hope my accent will be good for you guys. Yes, Abel and Proscovia did mention to me that we needed an introduction to R, and I thought maybe we should share something. Sorry for those who are already conversant with R. Actually, I've been advised to keep it as simple as possible so that then those who are going to are getting introduced into R might master the skills and how to maneuver. So I'm going to make this an interactive session. Feel free to chip in, feel free to talk at any point, feel free to raise your hand. And I'll request that everyone actually have their R open. So I just want to know whether there is anyone who doesn't have R installed in their laptop or who doesn't have access to their laptop at the moment, because I'll be expecting people to follow through. If you think there's a better way to an approach that I'm presenting, please feel free to chip in. If you think you haven't understood and you need me to come again, please feel free to stop me at any time. So I assume everyone has access to R at the moment. No one needs to install R. And I'm just looking through your names. I believe Bashir, you have access to R. Calvin, Jesse, do you have access to R?
Yes, please. I have.
Calvin has. Jesse, you have?
Yes, I have access to R.
Rose, I know she has. Phoebe? Phoebe? Solomon?
Yes, I have.
Solomon has. Thank Solomon. Victor?
Yes, I do have R. Thank you.
Thanks, Victor. And finally, Michael.
Yes, I do have.
Thanks. So, guys, we can start.
Robert, I also have. Sorry, I was struggling to unmute.
That's Phoebe. Okay,
yes,
thanks.
this is Phoebe.
So I'll open my R Studio. So we do have two forms of R. We have the IDE, which is R Studio, and we have the R GUI. So IDE actually is more user-friendly and has connection to other languages. So if you can actually connect R to other languages using the IDE. So and there's what we call JSON that makes it possible to communicate between different software. So R GUI is difficult to use, not user-friendly, so most people prefer R Studio. I'll just open my R Studio. By clicking on it, you can open your R Studio wherever you are. We'll just give it a moment. Unfortunately, I was working on some work, and I'll just close them all. And so this is how everyone's art presents. If you want to change your color, so some people prefer having white, so I'll just have I don't know which one. Is this clear enough, Abel, from your end? Are my codes clear enough, or I think they're clean to white? Okay. So I'll work with this if this is clear. So this is the R interface. And unfortunately, I'm working on a project, so you're seeing there's something here. But assume there's nothing there. So we want to understand the interface of R. The first thing is that you have four compartments. So this is where you write your scripts from, the first compartment this year. This is where you write your scripts from. And scripts are codes, basically, that actually impact on your data set. So if you are working on a data or you're working on some work simulation, this is where you write your script. And scripts can actually be saved. So whatever you write here will be saved. But on the contrary, if I just write 1 + 1, and I hit run, the answer will appear on the console. There's a console here. So console showcases the output of a script, or rather the script window, but also is a place for doing rough work. If you think that you want to write a code that doesn't necessarily have to be saved, you can use the console to write it. And in your console, you don't have to hit run, you just press enter. So you can do 2 + 2 + 2 times 3, and then click enter. But this won't be saved. Only whatever you're writing here is what will be saved. So that is the first point. We have a terminal, and we have background jobs. So for the terminal, so personally, what I use for terminal mostly is to exit from my working space and set up another working space. Mostly people don't use a terminal, but I do it to exit from my working directory, sorry. So when I just try to exit, I'll need to set a new working directory, which I'll show you. But most importantly, so most of your R actually, I just want to put it as it is in your, so panel, sorry for that. So your console is down here, I believe. And there's an environment here. So environment will show you
Robert.
all the objects.
Hi, Robert.
Yeah.
You were talking about the terminal. I think I didn't get you well there.
Yeah, I was just saying that the terminal, most people won't use the terminal, but personally, I'll talk about what I do if someone has an additional idea or other comment on how best to use, or the other additional users, they can always chip in. So whenever I'm working in R, you can specify which local disk to work from. So I'll just open any local disk. Say I have, so I have a folder here on mathematical modeling, and there is data analysis. So I want to work on this folder specifically, and I want everything to come from this folder. This is how I can tell R that everything I'm going to do, let it come from this folder, not my computer. So you have to set what we call a project. Right now, my project has been tied to a folder called LFMD analysis. If I want to exit out of that folder and direct my R to a specific folder that it will work on from now henceforth, I'll just write exit in front of this command. So this command is already here, specifying that there is a folder in place, or rather there is a directory in place. So if I just write exit, it will exit from that folder. And then I can set a new directory, which I'll show you. So that is how I use terminal. I don't use terminal as much, but I believe people who actually do renders do that a lot. And environment is to our right. So the beauty of R, whenever I'm working on a data, so say I have saved a data as HIV data. And this data is actually in my local disk, and I've imported it into R. I'll show you how to import. Whenever I have that data, I can make some changes onto the data. Say, for instance, I have 5 columns and 20 observations, 20 rows, and I want to add a new column. If I want to add a new column to the data, that is an improved version of HIV data, and I can call it HIV data 1 because it's an improved version. It's not exactly. It has 1 additional column. The beauty of R, you can save them in what we call objects, so that each and every improvement you make on that data, you keep updating it and giving it another name, So then if you want something from a previous object, or rather previous form of the data, it's always stored there. And this is where you can see all the objects that you've created. So for now, I'll remove everything so that then We start from scratch. So this is where you can see everything. So for instance, I'll just show you something. I want to store 1 plus 1 in object 1. And I want to store 1 plus 1. So this is how I'll write my code. I'll say, I want to create an object called object 1. And let that object 1 be actually 1 plus 1, the outcome of 1 plus 1. So I'll assign it using this symbol. This symbol is used to assign. Let me know if this is not visible enough. I can always change the appearance of my screen. So when I highlight that and I click run, object will come here. Such that I'll always know object 1 is 2. So if I want to work on something to the outcome of object 1, say add 2, will not go back and do 1 plus 1 plus 1 plus 1 plus 1 plus 2. No, I'll just do object 1 plus 2. What will that do? It will take the outcome of object 1, which is 2 plus 2. So if we do this, it will give us 4 because it knows there's something called object 1, which is actually an outcome of 1 plus 1. And you can actually even save this in object 2. You can assign that. So then you tell R object 2 is actually object 1 plus 2. So then when you assign, you'll get object 2, which is 4. So whenever I want to do something on object 1, I will not type it again. I will not have to minus object 2 from object 2. I just call object 1 and do the operations on it. Whenever I want to do something on object 2, I just call object 2 and do operations from it. So that is the purpose of environment. Now, these are saved. They can be saved as vectors. They can be saved as data sets, whichever. And then the history, as you can see, it tells us the history of the codes that we've run. You can go here and get them. So initially, I just updated my R before I restarted it. So these are all history from what I've been doing. And then when you need to connect your R to a server and database, this is the place that shows you the connections. And then if you have a GitHub account and some of the tutorials, I believe Abel will be taking us through GitHub account. So this is basically a place that you can track your progress from or other connectivity. But how do you work with tutorials? So in R, we have packages. What are packages? And what are libraries? So when you want to run some operations, say multiplication, division, addition, t-test, because this is a statistical program, ANOVA, binary logistic, linear model, mixed methods, method model. All these, they're specific packages. Think of them as a toolbox. You have a toolbox that has a spanner number 17 that can actually change my wheel. It has a jack. So there are tools within a spanner. So a spanner box, sorry. So this spanner box has different tools. So the spanner box is a package. Let's say, for instance, we have a package called Tidyverse. Tidyverse has there are different functions you can actually call from Tidyverse. And these different functions are the tools within that spanner box. So if you need to open the bolt, you need a spanner. If you need to apply the car, you need a jack. So depending on the operation, if that operation is for opening the wheel, you'll take a spanner. So for instance, if I load library, now R has some base packages and you can get them here. But this one will show you even the packages that I've installed. So other functions call for special packages that do not come with R. And case in point, that is Tidyverse. You need to install them. And for you to install, you need internet connectivity. When you install them, you'll all see them here. And packages that are active are actually highlighted. So this checkbox is checked. Packages that are not installed, that are not active, they are not checked. So for instance, right now, Tidyverse, the one that I want to load, tidyverse. Tidyverse is not checked because it's not active, but it's there. If you don't have tidyverse, how do you install tidyverse? You just do install. You tell R, I want to install packages. So you click that or just click tab. Sorry, my R has hung. Install.packages. And then, because you don't have the package within your R, it is a foreign object. It is not something that R understands because it's not within it. And for anything that is foreign, it has to be typed in quotation marks, double quotation marks. And then you write the package. And remember, R is case sensitive. It has to be the correct case and the correct spelling, tidyverse. When you run this, tidyverse will actually install. You'll see it. But because I have it installed, if I want to activate it, I just do library and then tidyverse. Now, because it is in R, R understands what it is, and I don't have to put it in quotation. And when I have to, I just do that, and then you see it is checked. That means I have my toolbox ready. I can get all the functions within tidyverse, like mutate, can actually do mutate, you see. And tidyverse is a function, is a combination of dplyr and tdr. So, sorry, of dplyr and tdr. So this one, tdr, sorry, tdr and dplyr gave, these are what gave rise to tidyverse. If you want to see all the functions that are in dplyr, you can just do that and you see all the functions. Summarize what, but if you want to see all the functions in tdr, and all of them are in tidyverse. Now I can access all these functions, and these are the tools I'm referring to from my toolbox. Now help. From here, you can type anything. I want to do mean. If I do mean, it will tell me there is an arithmetic mean, and how to get mean is just a function. It's called mean of x. And if your data has missing values, you have to specify remove them. In.remove is equal to true. If you want to do t-test, you just do t.test, enter. Tell you there's a student t-test and how you use it. T-test, you have to have two groups, X and Y, and then you specify whether it's two-sided or one-sided less, one-sided greater. And then if you have the mean or the mean is 0, and whether it's paired or not. So here you can get another way to get them. You just come here and type a question mark and type the test that you want to run. T-test. If it's a package, just do double quotation marks and do tidyverse. So it's still loading, as you can see. It shows that it's still loading, but it will run and it will show me all the tidyverse functions. You see? So it will show me tidyverse and what is it that I want to do in tidyverse. Much of the interface or the viewer. So sometimes you're doing what you call R markdown. And R markdown is render. So R markdown, you can actually prepare a document within R instead of doing 1 + 1 is equals to 2, and then you go back to R and type object equals to 2, you can create a whole document in R. Word document, PDF, HTML, PowerPoint. And this is where you'll be seeing them from. And you can actually render them. And even presentation for PDF. Oh, sorry, for PowerPoint. Now there's something important I've not mentioned. And this is where we're going to start from. So we're going to connect this R to a specific folder. And that is called setting up a project. Or working directory. So as you can see, my working directory R is telling me that I'm inside home or other documents, there's a folder called LF. Inside LF, there's a folder called analysis data. Inside analysis data, there's a folder called LFMDA. So if I just go here and go to documents, I do LF, and then I go back to R. It's telling me from LF, there's a folder called analysis data, and then it's telling me inside analysis data, there's a folder called LFMDA analysis. So I did set up a project, and this is the project. And that is why you see there's LFMD analysis. Now, everything that is here is actually showing me all the content of that folder. For instance, we see that we have 2018-2019 folder. I just said MAT, KE, CSV. So if I just come here, you see we have 2019-2018 data. So all these files are there. And just to show you that is the case, I'll copy any file from here. I'll copy any file from here. It's called MR and mastitis, sorry. And then I'll paste it there. And then I'll come to my R. Sorry, I need to move this thing. You see, AMR and mastitis is now in that folder. So just take it back. Okay, it's still there. Just delete that from there. So how then do you connect your R to that specific folder? So after you've exited from, so I believe if you had a folder connected, you just exit. And then when you come to home, it will show you all the folders in your document. So for this specific, I want to go to which folder? Let's see. I'll go to, I want a folder that has a data. That has a data set. Let's see. I need to choose the data that will work on. Okay, we can use this for a start. So I want to go inside this folder. So it's in documents. It's called mathematical modeling and data. And yeah, just that. So I'll just do here, documents, mathematical modeling. So mathematical modeling, and then data. Yeah, here. And then I'll press more, and I'll do set as working directory. And then automatically this part will change. So all the files within that folder, there are so many ways of setting working directory. Different ways. You can just do set WD, set WD, and then you come here and copy the path. And how you copy the path, I struggle with this thing a lot. I don't know if this is how I can hide it. So whenever you're in that folder, another way you can just come here. So you see where there is this path. If you just click there, it will give you the path. So I'll repeat. So where there are these documents, mathematical modeling data, just click there, and then you copy that. You come back here, and then because R, it is foreign to R again, you put it in double quotation marks. Set WD, and then you paste it there. Now, something else we need to do, R understands either double back or single forward slash. So you either use the two. So we can decide to do double. Someone can use single forward. So when you do that, it will also set working directory, but we did it manually. So that's another way. Now, I need you to connect your R to a specific working directory, and then we can start the conversation. So I'll just pick on a random person and see whether we are together. Solomon Wafula. You know, Wafula in Kenya means you are born when it's raining. I don't know about the case in Uganda. So I've just picked on your name randomly. Solomon, are we together?
Yes.
Yeah, so can you comfortably set a working directory now?
The what?
Can you comfortably set a working directory on your R studio?
Convert?
Pardon, you can set a working directory. You know how to set a working directory?
Okay, let me do that, please.
Yeah, so maybe just try it and see if you can actually connect your R to a specific folder by specifying the working directory. Now then we need to save
Should
these
do.
scripts. So then we proceed. I'll do save as. And you can see automatically it has taken me to that directory. And I'll just do intro, then I'll save. So the next thing is we need to call some data. And remember, we're working from one folder. So if you need to remove this, you just type here. I'm typing here because I don't need to save that code, but I can always type here if you need me to share the code. So remove, space for remove, and then the list of what you want to remove is actually everything. And then it will clear everything. If you want to clear your console, you just click this brush. It will clear the console. So I want to load some data, and I have two sets of data here. I have a CSV and a XLSX. So CSV and XLSX. So those are two different formats. And for me to check the format, I'm actually checking dot to root dot. Let me just increase. Root.csv to root.xlsx. If you want to check that from your folder, you just come here. Increase this, okay. So this to root, this to be xlsx. If you can check it from, it's actually saved here as Microsoft Excel worksheet, and this is comma separated value CSV. But you can right click and say job properties, and then you'll see the actual format here. And this is very important when you want to import data into R, because the format defines the function you're going to use to call that data to R. So that is that one, and this one, I'll just repeat, right click, then properties, then you can see it's a comma separated value CSV. So I'll come back to R. I'll call the data, I'll just call it what it's called. I don't know even, oh, I know why it's called that. So I'll first demonstrate this using R-based packages, and then I will demonstrate using
Excuse me,
installed
Robert.
packages, which are better. Yeah.
I wanted to ask you something, that if
Yes,
you're
please.
setting the directory,
Yes,
must
please.
the folder only be in C? Or it can even be another disk drive?
I believe it can be another one. If you have D, it's even better because my laptop is not partitioned. But I've had problems with people who are setting directory from the downloads folder and sometimes desktop. So for you to be safe, just put it in D. Or if you want to get it from downloads, then you can go to downloads and use the other method. You just copy the path, and then if it's desktop, just go to desktop, copy the path, and then you come and use actually setting working directory, set WD. But
Right.
you're safer having your files in documents, or rather D or C if it's not partitioned.
Yeah.
Are we together?
Yes.
Anyone else who was a challenge setting a working directory? Did you succeed in setting your working directory? Okay. So I want to call this
But I
data.
got an error.
You got some error?
It says it's unrecognized.
Okay. Do you mind sharing your screen? I'll just stop sharing and then we'll see from you. Oh, so, we can see some mistakes here. I'll give one person to point out any mistake from that code.
I think the quotes are outside.
Thank you. That's the first mistake. The quotes are outside the bracket.
I
Remember,
tried both. You can see here. First they were in, then I tried out, but it still refused.
when they were in, it was less of a problem than this one. So just bring them in and then we solve the second problem.
I also think the slashes are the other way around.
Thank you. The slashes are the other way around, or they are not double. So you either use that as double or the other way around. So there is one on top of, together with the question mark, on top of left arrow. Yeah.
Yeah.
So try that. Now it has run. And for you to know that you're actually in that specific working directory, there is how you can check. So just type get WD. Get WD.
I run that.
Yeah, and then, no, yeah, and then brackets. Run that. So you see in your console, it's telling you the folder than actually inside.
Okay, thanks. Though my name here hasn't changed.
Yeah, because this is not a project. This is setting working directory. We'll create another project.
Thank you.
Okay. So thanks for that. I believe now, yeah, we learn through mistakes. And for you actually to learn, bring them out right now. And thank you so much for that, Phoebe. I highly encourage that. You'd rather learn less of the concepts, and grasp them than learn more and miss on a lot. Now, we want to pull this data to R. I'll start with the CSV. So, and when it comes to R, I want to give it a name. So I'll call that data IDEMO. I call that IDEMO. And then when you want to assign something to the name, this is what we call assigning to an object, creating an object. And this object, I want it to read .csv. And that is why it is important for you to know the format that your data is saved in. And because I'm in that folder, I don't have to specify. Yeah, it's not still within R, so I don't have to specify the path because we're in that path, but the data is not within R, so I'll have to put it in quotation mark. I'll just type TUR, TUR, and if I do tab, it will give me all the options, all the names that start with TUR within my folder. And I'll actually tell R that I want to pick on. And then I'll run. So the short form of running a code is Control Enter. And you see, IDEMO is here. I now have an object called IDEMO, and it's actually a data set with 150 rows and 9 columns. Before we start exploring this data, let's load Excel data. So I'll call it IDEMO 1, and then I want to assign to that name an XLSX, so read.x. So sorry. Now for Excel, I have to load that package. The base package for XLSX cannot handle that. So I want to load, so I work with I work with the library. So there is read Excel. If you don't have this because it's not within R, you have to type install.packages and then in quotation that one. I'll send it to the chat box. So then you first run this and then we move as a team. So I'll give us 30 seconds for that, for everyone to run that. Make sure you're connected to the internet. And then we're going to use read Excel to load the XLSX data. In the meantime, let me do something to my exact data. So I believe everyone is there. Now I want to load that data, and this data, I've done something to it. I've created sheets. Sometimes you have an Excel data that has more than one sheet. I'll show us how to call the first and the second sheet. So the function will come from this. So you have to run library read Excel. So you have to activate it actually. You remember when we come here to packages, when you say read Excel, you know, it's not yet active. So for you to activate it, just control enter. It's now active. Now we have the toolbox. You can use the tools within it. And one of the tools is that we want to load item one, which is actually the Excel file. Now we'll use the read. So we can use read Excel. I like using this one. So read underscore. Let me just check something here. So read underscore Excel. And I'll put in quotation marks because R doesn't know that data yet. And the data is here. So I'll just do to root tab, and I'll see all the files I want this one. So when I do this, it will automatically bring the first sheet. That's why you're seeing 92 observations. And you can see here, should be 90. The first one should be 93. 93 because the first one is definitely the column headers. So 92 observations. So automatically, R loads the first sheet. But you can specify afterwards. You can specify the sheet is equal to. Now, when you want the second one, you just write 2. And you see we now have 150. And then if you come here, you just confirm, we have 151. The first one is definitely row names. But you can, if you don't want 2, you can specify, you see, the name called 2. So if you run that, you see 150. So I'm wondering why we have 7 observations. Yeah, it's 7, okay. 7 variables. So that is how you can read the first and the second sheet. And you can use base. So for this one, read.csv is also, I'll do a demo 3. This is a package that you can install. It's called read R. So for me, because it's already installed, it's called read R. You can install using the same function or other code. Install.packages read R. Or if it's installed, it's just do read R. So you can actually do read underscore CSV. The importance of this is that you can actually specify the number of rows. If you come here and just type question mark, read underscore CSV. And then from this one, we can see the delimiter, is it a comma or what? But then there is where we can say, we want to skip how many rows, we want to trim, we want to select specific columns, and then keep empty rows, a lot of arguments that you want to use. A lot of arguments. You can read this on your own. So you can use either that, and if you specify to root.csv, still it will come. And you see we have a demo too. So those are the different ways. Now, one thing that I have experience on is whenever you're loading or rather calling a huge data set, and you don't have the advantage of working directly from a database, it is troublesome when you use these functions. I have actually a bad experience using read.csv because then the data comes as distorted. Some of the columns are distorted, some information goes to different columns. And it takes a lot of time. It takes a lot of time because then your machine uses the heavy lifting. The data is not in a server. So the beauty of R, you can connect your data to the server using R, SQLite, or DB, packages, whichever. But then there's a function that I've actually realized that is better when you're loading a data that is heavy. And I have some data here that are very heavy. I'll just use the example. So I'll call this, any of this data here, I'll call this Bungoma data. It's quite heavy, you see. 61 MB. Actually, I'll call the heaviest. So then we can appreciate. So I'll try and call this is for P. Now, I'll try and call CSV first. Let me work with a CSV file. I'll call this another CSV that is actually heavy. Let me see. So I'll use this because I believe these are comma separated. Yeah. So you can see this is 300 MB. So this data, if you call it using that read the CSV, sometimes I get errors and it takes a lot of time. So what I do, there's a package called data.table. So just do install.packages, and then data.table. That is if you're working with heavy data. But for me, because I already have that package, I just do table. So you can install that package. So we are still including data into R. We haven't gone to another concept. So I'll call this idemu4. Actually demo 3. And now there are two things here. You see, I'm in a different path or other folder from the folder that I actually want to get the data from. This is a totally different folder. So how can you call data into R when you're not in that folder? So just do a demo and then read. Now, here is a function called read. Read is from data table, as you can see. It's a function called read. And I use it a lot when the data is heavy and it's in CSV format. So just call read. And then if I want to read data from a different folder, from the folder that my directory is on, I have to specify the path. So I'll just come here and I copy the path. So to that folder, you click here. Again, to that folder, you click there, you copy that, you come inside those quotation marks, and then you paste. But remember, they have to be double or single. So I'll just put mine as double, single, instead of converting them to the other one. Now, as it is, that is just the path. There is no data here. Because my data, yes, is in that path, but this is the name of the data. So I'll copy that name as it is. And then at the end of the path, you add another one. Other slash. If you used forward single, you'll just add one. If you use this backward double, you'll just add at the end of the path, and then you paste the data. But the data as it is, it's just the data name without the format. So you say .csv because it's in CSV format. And then when I load it, it's still taking time. And I promise you it would have been worse with CSV. And that is it, it's done. And a demo has 160,000 rows. So if I want to delete that, just to remove a demo 3, and it's gone.
So
So that's-
what would happen? What would happen if we used the read CSV? Would it have read?
Yes, but it will take a lot of time, number one. And number two, I have a bad experience with it. Sometimes the columns come distorted. So let me just read the data again, and I'll show you what it means, what I mean by that. So I was working on a data at some point, and this data had so many observations. So if you want to open the data, you just click on it here, and it will open. Just click on it here, and it will open. So sometimes you get some observation from this column are actually distorted and placed in that column. I just have a bad experience. The data will get mixed up at some point, not a must, but it might take a long time. We can try a demo 4. So because it's just that code. So if you want to get the previous code, you just click on the console and click the top arrow. It will show you all the codes that you've run recently. So I can use read underscore CSV, and then I'll call it a demo 4. And then we can measure the turnaround time. So it's still loading. So it's still loading. So you can imagine if you have 1 million rows. Of course, Excel cannot take more than 1 million, but you can imagine if you have so many rows, it's still loading. So you can see the amount taken for the other one is shorter. So that's it. So we've already loaded our data to R, and they're all here. Now we want to take a look at our data. We investigate the data. We want to understand the data. We want to understand the structure of the data, how the columns are like in terms of how R understands the column. Why? Because that is important when you want to analyze the data. So for my case, if you want to see iDemo for the data itself, the way it's seen in Excel, iDemo, you just click here, or you can do view, iDemo. Or if you're using tidyverse, but I'm going ahead, I'll show you. You just have to type Shift Control M, or you type manually % greater than %. The short form is Shift Control M. But I'll talk more about pipe, and then you just do view. So any of this will open the data. So if you do that, it will open the data. If you do this, it will open the data. If you click here, it will open the data. So then you can inspect your data. You can see, okay, I have organization level 2, 3, 4, 5, organization unit name, the code, the month, the year, and the incident. Okay. And these are the specific hospitals. See, and this is maybe the ward or district, province, and then the county. So now that I have that data, I want to understand the structure of the data. Now, 2 things. You can either type structure, str of the data. Now the data from here henceforth is called iDemo, but because that's the name we gave it. So when you're born and given the name of Fwete, everyone will be calling you Fwete, so long as you're alive and in that R. So from
Excuse
here
me.
henceforth, yeah.
Excuse me, Robert.
Yes, please go ahead.
For example, if I have a demo 2, a demo 1, where we had read CSV, read Excel, you find from the where we have them in this directory, where we have the mathematical modeling, then data, they already here, there.
Here.
What if,
or here.
Yes, you can see
now,
it. What if I want to read now from the papers that is still under there?
You want to read from?
That papers that is there, the paper folder that is in that very directory. Yes, that one.
Oh, I get it. So these 2, a point of correction, are not in that folder. That's why I had to specify the path. Number 2, this is the only data that is in the folder. That's why we are not specifying the path, and we're just calling. But you have a good question. What if we want to read from a folder within a directory? So I'll just do a folder within a directory that has a data. Oh, let me check. Oh, I think there's some data here. Now we want to read this data, yet our working directory, if you see get working directory, ends at data. So we have a folder within a working directory. So what we do, I'll call it a demo 5. Thank you for that question. But it's advised you keep all your data in one. So I'll demo 5. And then this is an Excel exec. So I'll just do read underscore Excel, or there is a read underscore Excel execs, XLS, so whichever. So I'll just do that one. And then now I will do quotation, incidents, you see, incidents and HS. That is the new folder. Within data, I want to read the data from, within that folder, I want to read the data from incidents and HS. So I'll just do IN and then tab. And then, you see, I'll do that or that, whichever I want to use. So, sorry, it's either that one or these two. So because I automated it, it gave me the correct one. And then I want to read clean, do tab. It has given me automatically because it is the only one that has CL, named as CL. There's no any other one. So when I read that, control enter, and it's there automatically. I hope that responds to your question.
Yes, thank you very much.
Yes. And now we have our data. We want to see the structure of the data. Now we want to dive into statistics. We want to dive into descriptives and inferentials. So the first thing we look at the structure. When you click that drop down arrow, it's the same as writing the structure of data. It will give you the same information. Now here it's telling us the first variable. So just do this so then you can see them all. So it's called organization level 2, and it's a character. So R is understanding this thing is a character. Why? Because it's a string variable. It's in letters. It's a word. It's in letters, written in letters rather than numbers. So this is a character. This is a character. This is a character. And this is a character. And this is a character. Because they're written in letters. But for my case, I don't want that. Why? Because this is a one county. And within that county is divided into organization level 2s. So this county is divided into those. So this is like a province into districts. And then these sub-counties, so these are the sub-counties. You can see there's this sub-county. These sub-counties are further divided. So these sub-counties are further divided. Let me see. How can I pick on another color? Okay, I hope you'll understand. They are further divided into sub-counties. So this into wards, sorry. So this specific sub-county administrative unit or other province in Uganda is divided. So in Kenya, we have national and then counties, so you can relate. And then within a county, we have sub-counties. And then this sub-county has wards. And so this is not a character, this is a categorical variable because I can actually pull this and categorize them. It's a categorical variable. They are mutually exclusive. You cannot be in two counties at the same time or two wards at the same time. So given that, I want to tell R, this is not a character. This is a categorical variable. So that's what I want to do. So the first thing is to make R understand really how these data are in terms of the data types, assign them to the correct data types. So there are many ways. For my case, if I want to convert to factor a number of variables or numeric, I use sapply and lapply respectively. So there's the apply family. But for this case, because I was asked to keep it simple, I'll show you how to do it individually. Now, my data is called idemo. If I type idemo, I see the columns here. But I want to change this specific column from a character to a factor. How do I specify a specific column in R? Because idemo is the whole data. So if you want to tell R, in this data, go to a specific column, you add a $sign. And then you specify which column is that, actually this one. What do you want to do to that column? You want to assign it, refer to it as a factor, because it's a factor categorical data, as a factor. And then R will ask you, what specifically in that column do you want to assign to as a factor? And they just tell R, I want to assign the whole column. So I'll repeat. I want to assign this organization level 3 to a factor. What do I do? Because that is a column within a data set or a variable within a data frame, I just do idemo and then a $sign to refer to a specific column. And then I say refer to it as a factor going forward and not, there is as.numeric, you can refer to it as a numeric, as.integer, or as.character. No, I want to change from a character because going forward, I want to realize that my observation are actually grouped based on this variable, Because if you come here, you see this sub-county, I'll start with this word. This specific word here has a number of observations. And then if you go to another word, has a number of observations. So I'll do as.factor, idemo, the whole column. So organization unit 4. And if I run, so if I run this, automatically it changes to a factor. So I just want you to look at this organization unit 4 as I run it, automatically changes to a factor. So if I check the string, it will tell me now this is a factor. But you can also check, if you use sapply, I want to check in idemo the classes of all the variables. It will tell you that now this is a factor and this is a factor. So based on that, I want you to try and convert incidence to a numeric and not an integer using the same logic. So I'll just pick on anyone randomly. Vic, in a position to speak. Can you please help us convert this column called incidence to a numeric based on this logic? Victor?
Okay. Thank you. It's quite noisy place, but I hope you can hear me. So what we are going to do is we just do idemo $sign, and then $sign, and then we do the
column.
Yes, and then we do the sign which is greater than or on the minus thing, and then you said we should convert it to numeric and dot numeric, and then yes, and
then we repeat the same.
Yes.
Thank you so much, Victor. And automatically it's now a new. And if you check the class, and this is numeric. Now that is one way. So the other way is now we want to get into IDverse. IDverse has actually been created to make work easier, things easier. To prevent you from running and assigning so many objects, yet you're just running the same operation. Or you want to update a data set to IDEMO maybe A, and have IDEMO A as the one that has these variables as factors. So I'll call this to be able to convert everything back to character as they were. And then I'll give you the second method. So in tidyverse, what you do, you call first IDEMO. And you say, I want to create an object called IDEMO A. And I will ask you, what will that IDEMO A contain? So I want that IDEMO A to be IDEMO, but with some changes. Okay, what changes do you want? So the changes that I want, you pipe. That is called a pipe. Shift Control M, the short form. Percent greater than percent. I want to, so there's a package here again called, so R is all about packages. So it's called that one. So you can either load it, or I want to go use this package. This is how you specify the package. And modify that. Where do you want to modify? Now I want to modify, what do you want to modify? Different columns. So these are the columns I want to modify. This one, this one, this one, and this one. And this one. And I want R to refer to them as factors. Whenever you are listing more than one in R, you use a concatenate function. In Excel, it's actually called concatenate. Whenever you have, maybe you say here, concatenate this one, comma, this one. So it will add the 0. Or maybe you want to say concatenate that one, comma, that one. It will say 2020 July, depending on which one. So you are listing so many. But in R, you just do C. And then you start typing the column. So that one you separate with a comma, 3 with a comma, 4, and 5. So this bracket here holds the list. So you have to go outside the bracket to be able to activate this function, because this function is within the first bracket. So I want to refer to all of them as a factor. But then this function requires them to be there. So this is a simplified way of doing it, instead of just repeating all this. The beauty is that now you'll have IDEMO A, which will refer to them as a factor. So if you run that and you do sapply, what is that code of sapply? Okay, you do if you check IDEMO A, the class of the variables, usually those are now converted to factors in IDEMO A. But if you look at them, they're still retained as character in IDEMO, but in IDEMO A, they are factors. Why? Because we actually assign them. We want to do something to IDEMO A. We are not changing IDEMO. We are not changing IDEMO, but whatever the changes that we're going to make to IDEMO, we want all of it to be affected and stored in an object called IDEMO A. And that is why you see IDEMO still retains the original form of the data, but IDEMO A actually has the data as factors. Any question? I can see Victor. There's a hand up from Victor. Go ahead, Victor.
Yes, I have a question. Maybe just to repeat again with the is it function or the package, the PURRR? I really didn't get this. When to use it?
Okay, PAR is used for mapping, but then there's a lot of functions in PAR. You just do this. All these are functions within. These are the tools within that toolbox. All this, but then modify at one of the functions for modify at, or rather one of the importance for modify at. If you want to convert to factor, a number of variables all at once, it can actually come in handy. Say, I want to work on this variable, on this data set, these specific variables. You list them. And it will ask you, if I remove that, that is where I listed it. Sorry. This is the last. So you can see this modify as it's opening and it's closing bracket. To mean, what are you modifying should go here. And what do you want to modify to? You just want to refer to them as factor. So this first part before the comma is where you list those specific variables. And because you're listing more than one, you put them. Because you're listing more than one, you put them inside the comma.
So in a sense that the par package, it's mostly associated with the modify object. So whenever you are using it, you also have to use the modify it.
Not
if
really.
I'm getting it right.
Not really. This is one of, this is like a toolbox. It has a lot of functions. But a function that can give you this result is modify at. It has other functions. And the reason why we are specifying this, let me just see. So I've forgotten the function, but there's another package that has this function. And that is why you are specifying, I want to use this function from this specific package. That is why we are having this package here. But hey, because this is a beginner, let's not mind about this. I can actually convert them to comments so that then anyone who wants to use them can use it. So just go with the normal way.
So is this a new package on its own, or it comes with dplyr?
That is a different package.
Okay.
You have to load it.
Okay, thanks.
So I've converted those. If you want that, I'll share the script. You just convert them back to your code. You highlight Shift Control C, Shift Control P. Now, what else? Now,
Robert.
Yep.
Well, I beg your pardon with the percentage, greater percentage, that symbol or the combination of those.
Okay, I'm going to use that a lot. So I'll just tell you what it means. I'm going to use that a lot. When you want to, let's say you're doing 1 + 1 and we stored it under object. And you want to make improvements to 1 + 1 by doing object +2. I'm just giving an example. It might not work here, but I want you to understand. And then this one is stored under object 1. And then you want to make an improvement and do object 1 divide by 3. And you store this under object 3. Now, you are doing a lot of objects. You're creating a lot of objects that might get you out of control. You might lose control and track of the objects. So tidyverse as a way of combining all these functions without necessarily creating so many objects. So then you come up with the end result, which is object 3, without having to create so many objects. So what you do, you just do 1 + 1, and then the results of whatever is in the left, you want to maybe do that +2, but this won't work, but I'm just showing you. Then the result of whatever is the actual thing to the left, the immediate left, you want to do it divide by 3. So how it works, this will give you 2, and then this will add the 2 + 2, it will give you 4. And this will actually work on the result of what is here. So if you type whatever function you're going to do here will work on the result of whatever is to the immediate left. It's like a chain. It gives you a result and conveys it forward. It gives a result and passes it forward. So that chain reduces the so many objects that you have to create, and you lose track at the end of the day. Is that clear in terms of the operation of Python?
Yes, it's clear.
Perfect. I see we have 40 minutes to go, so we can make use of that. Now, I think now we can go into the statistics, just simple statistics. For my case here, the first thing we can do, let's get the sum of this incidence. Yep. So let's get the sum of that incidence. So I'll just do sum. And we want to get the sum of that incidence. And the incidence is a column within that IDM. So I'll just pick on someone randomly. Amina, you weren't here at the beginning. I'm not sure if you were here when you were doing that. I can see Victor's hand is still up. Do you have something, Victor? Your hand is still up? Okay, I'll take that for now. So Amina, if you don't mind, we want to get a sum of a column within IDM, and this column is this. So how do we refer to a column from a data set? You can borrow that from lines 19 to 21. Yes, Amina. So Calvin can help. We want to get a sum of this column, this last column, and the data set is called IDM. How do we specify that specific column? Because we already know the function is called sum. Calvin. So Victor has his hand up. Victor, you can help.
Yes, I want to help.
Yeah.
Okay, so I think now that you've already typed sum and then bracket, and then you specify the data, demo, and then $sign, and then the name of the column.
Thank you so much, Sam. That is true. So when you just do $sign, it gives you all the columns and specify. Let me tell you the sum is 27. But I want to do something. I want to add. So I want to specify a demo. I want to do a demo incidence. Okay. So a demo, and then this is a demo one. I want to call from my demo one. This is the 7th variable. So a demo one, maybe the 5th entry from variable 7. So the same way you have coordinates x, y. So x, the first one is the rows. So x, y, 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 y. So when I do a demo, that is the data, and then I do that one, square bracket, and then I say 5, specifies the 5th row. The 5th row is the 5th row, and then comma 7, that is the 7th column. And basically, I just checked the variable and I want to specify the last column. So I want to assign it NA. So, I demo one. I did that on my demo. I wanted to do it on demo one. Okay. I wanted to do it on demo one. demo has 9. So I want to specify to the last, so there are 9. So I just do 9 instead. So you can see here, it is converted to NM. It wrongly converted this. So I want to show something. When you have missing values, what is the effect of missing values? So now I have a demo again, but this demo now has a missing value, and I want to get the sum. So if I do that, so a demo one incidence, sorry. Oh, sorry. I read it again. So I think for us to be safe, let's put it on demo one. So demo one, column number 7, the 5th row. So if I specify this, you just see it will be an NA. It's NA because I'm specifying, please give me from item 1, give me the fifth row, from the fifth row, the seventh variable. What is the entry in that cell? Row 5, column 7. So go to row number 5, just go to row number 5, column number 7, that intersection. What is that value? It's NA because we've converted. So what is the effect of missing values when you're getting this, when you're doing these calculations, rather arithmetics? So when we come here and we get the sum of incidence from item 1, it will tell us NA. It will tell us NA. Why? Because it's a missing value. It's not applicable. So you have to tell R, remove those NA. N dot remove. You want to remove, yes, true. So either capital T or true. So for it to return the value. So whenever you have missing values, please make sure you include that. And this applies for mean. This applies for standard deviation. This applies for other. However, you have to be cautious and understand the impact of that, especially when you're doing means. Does it reduce your observations? And does it affect the mean or not? Please go and check that. Anyone who has a question on the effect of NA, because we can do basically mean. If we do mean, let's start with before I go to Victor, if we do mean, a demo, incidence, and then we come here and repeat the same for item 1. You see NA, we have to specify that we are removing the NAs from that observation for it to give us. Yes, Victor, you had a question. Please ask as many questions as you have. This is an interactive session.
Yeah, thank you. Thank you so much. I have a question regarding the NA. One time I was working with data, and I don't know if I'm getting it right, but it appears that maybe there's quite a slight difference between the NA and a blank. Maybe could you just comment on that? If I have my CSV file and I have NA and I have blank, is it more or less the same, or it's quite different? Thank you.
NA is the same as blank, and I'll just show you something. So this is true. I'll call this, I'll delete these ones, right? That's what you mean. So
Yeah,
blank
yes,
values.
yes.
So this will come as NA. There's no need
Okay.
of going back there, but this will come as NA.
Okay.
So I'll refer to them as NA. So how you handle them is how we've actually described.
Yeah,
So,
because I was once working with data and someone told me that, well, I should Google how to convert the blanks into NA. So if there's a blank, I should insert NA. And I did that. And that's why I'm asking, maybe there's quite a difference between a blank and NA. But yeah,
not
thank
really.
you so
They will
much.
just come as NA, not really. So
Okay.
I'll just call
Thank you.
that was this one, item 1. And then we'll do the sum of if it's NA in item 1 column incidents. You see, they are now 5Y because I removed some values. And now, why are they 5? Let's run item 1. And then you see, they are now converted to NAs. Automatically, when they are blank, R will know it's an NA. But if there's a character there, it will not come as an NA. So if someone inputted something, maybe like space, it referred to as a character, it won't be an NA. So I bet now we are good in terms of inputting data, looking at the structure of the data, converting to the correct data types, and doing simple sum and mean. Now, can we do some plots? And we do some t-test. So the first thing I want to do, I want to plot for the months of January to December. I want to plot the sum. So what I'll do, I want to work on iDemo. What do you want to do on iDemo? I want to group by I want to group by month. So that said, I think month wasn't here. Month is not a factor. So I'll just convert month to a factor, because then I want to group them together. And then I'll refer to a demo. I want to work on group by month. And what do you want? I want to summarize. I get summaries by month. What summaries? The incidence will now be the sum of the incidence and NA. So what R will do, it will summarize, it will get me the sum of values by month. Okay. And we can actually convert this in the correct order to be January through December, if you just specify that that is the order. But we'll do that. So I want to plot this. So sometimes you want to do it as a plot. You want to do it as a plot. So again, you can now we'll add another package. I'm afraid I'm giving so many packages. So ggplot is just for plots. It gives so many beautiful plots, but then you can just do a plot. If we decide to save these to plot data, and then so that when we click plot data, we have that. So we can just do, we can do bar plot data, comma, incidence by plot data, comma, month. So when you just do that, so we want to plot incidence in that plot data by month. And when you do that, it gives us this. So this is now the base R, but we will show it again using ggplot. And then you can specify the, so in here, when you want to specify the title, just do main is equals to title, and then x-axis is xlab is equals to x-axis, y-axis is ylab is equals to y-axis. So that's how we generate that plot. But then there's another way. We can use what we call ggplot. Ggplot is commonly used. Now for ggplot, you can either proceed from here, and that's the beauty of reverse piping, this pipe operator. You can just say the result of this, which is this here, I want now to do something else to it. What is it? I want to plot, ggplot. Okay, what do you want to plot? I want to map aesthetics, so then the x-axis is actually the incidence, this one, and then the y-axis is actually the month. Sorry, month. Okay, what you've mapped. So when you do this, it gives you like a bar graph. We used to call them bar graph, those books that we used at school. But then you've not plotted anything. So what is it that you want to plot? I want to plot a column. You see? So you see, it is going that way. But then you can actually flip coordinates. Chord flip, chord flip, if you want them to come that way. But then the good thing with this one, you can add so many things. So before we flip coordinates, you can come here and say theme. You want to play around with the theme. Now we can first add digit title. We call it title. When we do that, we have our title here. And now we can position our title center and have it as a bold. So we want to play around with the theme. Just say plot.title. We want to play around with the text. What element the text? What do you want to do it? You want to adjust it horizontally. Horizontally 50%, which is 0.5. So h just element text. So it has refused because we don't have a plus here. So it's now at the center. And we also want its face to be bold. It's to be bold. You see? And then we want black and white theme. So we can just do theme underscore black and white. So then you see we remove this. And then something else, maybe you don't want the month to be there because these are automatically months. Why again refer to them as a month? That is a chart, what we call chart junk, plot junk.
Sorry.
Yeah.
Sorry to ask.
Yeah.
The Facebook, what did it do? Facebook, I didn't get it quite well, and I didn't see how it even changed.
Okay. Without
Is
this,
it the
because we are referring to the title, it changes the face of the title to bold. Because initially it was in.
Oh, okay.
Yeah, you see.
Okay.
Now,
yeah, I see it now. Thank you.
Now something else we want to remove is so axis dot text, but then in the y-axis it should be, now the element should be blank. You see? No. That is, I've removed the text. I should have removed the title there. And then you can color these graphs by month. So what you do here, you just say fill is equals to month. Yep. And then if you want to remove the legend, you just come here. You can come here. Let's say legend dot position equals to blank. Yeah. So on and so forth. And you can even add these numbers here if you want and remove the axis. Then you can. Sorry, we had a question.
Yeah, I'm so curious with the Facebook thing. If you make Facebook equal to italics, will it make the title to be italics or only?
Let's try. I've never tried. Let's try, but it should. Yep.
Oh, okay.
Yeah, and you
All
can
right,
actually
thank you.
rotate. Sometimes you see how this when the graph is small, you see how these texts are eating into each other. So you can just do. You can do axis because that is text.x. You want to work around the text. You just want to change the angle to maybe 90 degrees. Yep. Now that's it. There's so many we can do, and we can't go through them all here. But that is the beauty of R now in terms of visualization. Yes.
What does the geom call mean on this code?
Geom call. So if we do this code until this place, we just have the graph itself, but we don't have a plot. It knows we want to plot some column on the x-axis because I indicated here, this should go to the x-axis, this should go to the y-axis. But I've not indicated what kind of plot do you want. Do you want a bar plot, bar graph? Do you want a, what is it called? Do you want a pie chart? Do you want a line graph? R is not clear yet. So you have to specify, I want a column graph. So column graph is another name for bar graph when you have actually values in one and categorical data in the other one.
I'm curious to know. So down here where you have the code x-axis.dex.x. So if you're dealing with the y-axis, that means we are just going to have x-axis.dex.y, right?
Axis.x.y, exactly. If here we say dot y, so
I see.
You see they've changed, eh?
Yeah, I see.
Yeah, but it's because of code flip again. Okay. Yeah, so it is specifying I want to work on the text within the y-axis. So on the axis, I want to go work on the text in y-axis or in x-axis. What do you want to work on? The text itself, I want to change the angle. The text itself, I want to adjust it horizontally to 50% or italic. The text itself, I want to omit it. The title, I want it to be blank. The element to be blank.
But what if you want to increase the size of the text?
I think you can do the size. You say maybe 0.9. That is the title. 0.9 is so small. Let's do 19. You see?
Yes,
Is that?
Yes, thank you.
And I'm not sure, maybe you can do, let's try, maybe you can do italic bold. So it's not correct. So maybe you can do face, then you do face. Let's try this. You know, this is an art. Now you can do things and try trial and error until you master the art. But when you don't know art is open source, you just go online and Google. So you can just come here to Google, let's see, Google, and you say, let's see, how to use Google to maneuver through your code. So whenever you're stuck, you can come here to Google and say, oh my, this thing is annoying. Plotting a column graph in ggplot. Plotting a column graph in ggplot. And then you see so many people have done it. This person has even added error bars. So you can pick RPubs. My internet is slow. Okay, we don't have time. So I'll do this one instead. See if it opens. Okay. Now this one will give you the codes. So you just copy the code. So here I say they assigned to object P, and then they inputted the data inside. Let's see. So let's say you want to plot this way. These guys have done even, okay, want to do this. So if you don't know, just go in here, copy. And then you come, you paste. So data, you just convert this to your data ATM way. And then x-axis, you want the x-axis to actually have the month. And then the y-axis to have the incidence. And then geomber statisticals to identify field specific curve. Let's see. Let's see. Works. So you can even Google. And it's because they've specified, you can actually specify they've specified the color. So you can, I wanted to fill it with all the colors of the month. So that's why I did this. If you have another variable, you can actually, if you have another variable, let's see the variable that we have. We have a variable for year. Year, let's do year. Field is equal to year. Let's try that. It's not there. How is it labeled year? A demo. Yeah. Year. But it's there. Oh, so you have to group by, because when you do this, when you do the first line, and then we summarize, we only have, the reason is because we only have month and incidence. There is no year. So R is asking, where is that year? So if you want to color by year, you can actually just add group by year and then month. So that then when you summarize, you actually have year, month. So for all the years, then it's easier when you bring here fill year. Okay. So it actually colors by year. And you can actually add here and say you want to facet the graph, facet graph by year. So you can facet by year. So you can clearly see here. Why? Okay. Stop sharing and then I share. Okay, you can see that there was nothing in 2016, nothing in 2017. 2018, we only had data from August. 2019, we had data from this, and this. 2020 from this, and this. So you can actually tell that even though we have data all through the months, the data are actually from different years are data from different months. That's the beauty of faceting. Yeah, can we use the remaining 15 minutes to do some of, maybe we can do t-test and over some of the inferentials. Are you okay with introduction to plot? I know I did it so fast, but then the idea is just to get the gist of it on how to go about plotting the different types of plots. You can do actually plot. You can just do.
Why we are here plotting, because I really find it difficult to do some plotting. Normally what I do, I just do my data cleaning in R and then I plot with Excel. So I don't know if your data would allow us, or even time, if you could just maybe show us on how to plot, I think it's called the combination graph, where you have like the y-axis on the left and y-axis on the right. I really find it really difficult to do it, and I think it's so useful because it actually saves time or space when you want to publish something, maybe data of maybe COVID-19 and TB together, where you can just have two graphs in one. I don't know if time will allow it, or even the data that you have, but I think it would be nice if we could just touch a little bit on that. Yes, something like that. So you have on the y-axis on the left and y-axis on the right, maybe a bar graph and the line graph all in one. Yeah.
And then the values, and then the months.
Yeah, I really find it so difficult.
You're the second person asking me this. I've not done it before in R, but I'm sure you can do it. So if we find time, if you can save some time tomorrow, maybe Abel can advise. I can prepare some thoughts on this and go through it tomorrow. So then we have time for t-test and ANOVA. Now let's go through t-tests and ANOVA. So t-tests, we know the group has to be 2, and the data has to be normally distributed. And the group can be paired, so those are the assumptions. 2 groups, the data is normally distributed, so you have ladies and gentlemen, and you're picking height, and that data has to be normally distributed. And the groups can be independent of each other. Ladies, you can't be both, so nowadays you can. Or it can be matched. You're matching a lady to a gentleman who fits the criteria in matched case control studies. Or it's repeated. You are taking the shoe size of this class now and 5 years later, or now and 2 months later. You want to see if it has changed. So that will define the kind of t-test. And ANOVA, the same applies, but the group have to be 3. That means you can either do ANOVA or repeated measures ANOVA. Now, I want to see if we have any value here. There's no here in anything. So I'm not sure if I'll have a data. So there's no data that can suffice this test here. So I'll convert this to only 1 and 0. So then we have 2 categories. I hope you understand why, because we only need 2 categories. And then I'll rename them to male and female. So then we have, instead of incidence, I'll call it sex. And then anything up from 1 and above, I'll assign them to female and male as 0. And then we'll assume this is the continuous data. And we'll check whether we are going to do t-test or Manu Whitney based on, that will mark our last session for the next 10 minutes. So we're going to work on a demo, and we say we want to change a column. What column do we want? First, we want to rename it. We want to rename a column. So we want to rename a column. You write first the new name, and then is equals to the old name. And when you run this, you'll see you now have sex. So I'll just pick the first 5 values. So you have sex instead of incidence. And I want to change context of sex. If you want to change context of a column, what do you use? You use mutate. And I want, in that column called sex, if that sex is greater than or equal to 1, or we can say greater than 0, whichever, then have it as female. Otherwise, have it as male. And then we can pull that sex and we see how many females and how many males do we have. So you can see we have a total of 16 females and 134 males. So we have them as 2. So I'll save this as a demo B. And then that demo B, when we come here, we have to assign this to a factor. So the same thing, demo B, sex. I have another meeting at 4, that's why I'm writing. Demo B, sorry, as that factor, demo B, sex. And then it's automatically converted to this factor. Now, we want to change this column here. We want to assume our outcome variable was this column here called year. Just assume year is some values, shoe size or something. And for each sex, we have a year, because we can actually do a demo B. Year, sex. So for each sex, there is a year, there's a measurement. So we assume this is shoe size. So this person, this male here, his shoe size was 2017. This male here, his shoe size was 2018. This female size, female here, the shoe size was 2019. Or this sample, this was the OD values from ELISA. Or this was the PCR, maybe if it's continuous value. So how do we check whether these values, so we have male here for category A and category B, and you want to get the mean value of this and the mean value of this. And you want to assess if there's a significant difference between this and this. And we get the p-value and we get the confidence interval. So, and report the mean value for male was blah, 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 and the female blah, blah, and the two values were significantly different as indicated in the confidence interval, encompassing the actually null value or rather p-value less than 0.05. So the first thing, assumptions for t-test, this data has to be normally distributed. How do you check normality? You can either do QQ, is it norm or line first? Let's see. So if you check from QQ norm and you plot a QQ line of that specific column, you see that this data is more or less categorical because there are categories. If it were normally distributed, this point could be swinging around this line. They're meant to be swinging around this line. So what do we do in that case? We don't know that when we do Wilcoxon sum rank test, which is actually Manwitri. So that we just do Wilcox test. And then when you come here, these are non-parametric tests for t-test when the data is not normally distributed. And it's just the same to t-tests, x, y, and you specify whether they are paired. So our x, you can specify, is idemo b. So we can just do this. We want to take the values of years along idemo b sex. The paired is false, so this is not a paired data. So you can just write false. So it's saying the formula is incorrect. Okay, because I specified this. So it will give you the p-value. So it will tell you, you want to check the values of shoe size or year with regards to sex, the two categories, and this data is not paired. So it tells you actually there is a significant difference. But hey, where's the significant? Which one is bigger than the other one? So the beauty of t-test, it will give you both, but I'll show you how to do it. So the only difference between these two formulas is that is the function itself. So here you just do t-test, test. So it will tell you for female, it was 2020, for male, it was 2019. And you actually see the confidence interval in the p-value. So these are the mean. But you can actually get idemo B. You say you want to group by sex because you want the mean for male and female, and you want to summarize. So sex is equals to mean of sex, or you can call it average size. Let's assume they were sizes. And definitely if they were NA, you're safer removing them. So mean sex, and sex is not a continuous, so we want the mean for the year. So it will tell you the mean for female, the mean for male. And you can proceed and plot. Ggplot, you add, so it will plot only this. So you add aesthetic, x is equals to now the sex, this column, y is equals to average underscore size, and then you want to plot a geom code. And then it will tell you. And you can actually add, so if you want to, you can actually specify the values here, 2020, 2021 is male and female. So the field is equals to 6. Yeah, male and female.
Is geom call different from geom bar?
Not really, but you just have to state identity when you're using geom bar. You're saying one of the column is actually for identity purposes. That is equal to identity. So guys, I believe that gives us a rough introduction. Apart from the last part, I hope the first part I was kind of slow and you got the gist of it. But the most important thing, you now know what to look out for and how to search for help online. And you come and navigate through your R and check all these things. All manner of tests and over. Actually, correlation, you can do correlation. IDEMO. Yeah, what is IDEMO? IDEMO 1. Incident. You can check everything and there is a missing value. So let's see if this will work. So it's refusing. So you have to deal with the missing values. Yep. So this doesn't have anything else. So you can tell the correlation between the two values or small, only 17.6%. That's it from me. I'll take two questions, one from Phoebe, if there's any other question, and then we call it quits. and then I'll pass it over to Abel. Phoebe.
Yeah, mine is not a question, just requesting that you could save, I don't know if it's called a do file, a script, the script, and you share with us because it's a bit familiar to enable me in particular to practice through what I've not practiced.
Thank you. That is the stated time. I'll save this R script. It's not called do file, like instead, and then I'll share it with Abel and or Pros, and they'll send it to the team, if that's okay with you. Any other question? If not, back to you, Abel. Thank you so much, guys, for your